Today I'm going to talk about process simulation software as a tool to help operations troubleshoot and to justify projects. Process simulation software has been around since the 1970s as a mainframe tool, software program mostly for PhD engineers and for software developers. In the 1980s, more user-friendly PC version simulation tools like Pro2, ProSim, ChemShare, and Aspen Plus were developed, moving the applications from the mainframe onto portable PCs that put it in the hands of engineers in the field. Now, even though the software is very powerful, it still takes the proper intelligent inputs to model systems and processes properly. Whenever you have simulation software, you model streams, you model chemicals, you pull from a library of components like exchangers and pumps, and you build the process, and then you run simulations of that process. Once the simulation is validated, you can do what-if scenarios, testing all kind of options on what happens if I increase throughput, what happens if I change temperatures, what happens if I add new equipment, a second pump, a new exchanger in parallel, on and on and on. So process simulation tools have always been the beginning of design, but also it can be used in the field to troubleshoot and solve problems. So here are some examples of where simulation tools can be used to solve problems in operations. The first would be diagnosing distillation column problems. Now, most distillation columns today are being pushed to the limits to try to maximize throughput for the asset, and a lot of these columns are operating in areas where they were never designed to operate. Maybe even with feed types they were never designed to operate with. So performing a new column simulation to match the original design and then try to simulate what's happening with the column can help diagnose problems in the column and can help troubleshoot if the column is flooding or not. Most towers are flooding, and if the tower is flooding, there are changes that need to be made to get the column back in operation. Another example would be additions for utilities like cooling tower expansions. With expansions in existing plants, the cooling towers are having to be expanded, adding bays, and maybe even putting in trash screens to block the trash from getting into the pump suctions. Is changing the hydraulics throughout the cooling tower. Well, a hydraulic study with simulation tools can be used to determine if the water is going to form vortexes where they weren't forming before, and thus you can make changes to prevent vortex formation if that's the case. Another example would be flare radiation studies. We can perform simulations of the flare based on the height and the heat from the PSV releases or any gases to the flare, and plot thermal patterns around the flare where the heat levels would be, thus making sure you comply with OSHA requirements for where workers who don't have protective clothing could be and where protective clothing is going to be required to work around a flare. Another example would be plume studies. These would be release of hydrocarbons from a PSV or from any kind of vent in the plant. We can simulate the effects of a cloud being released, where it would go with wind direction and speed, and how long it would take to dissipate. We can also do liquids as well, draining away from a tank. These are two examples of process simulation. PSV studies are another area of simulation. We model the inlet and outlet piping, do pressure drop calculations so that you can document whether the PSV is in compliance with API 520 and 521. We do this as part of an entire flare simulation if that's required. Final example would be dynamic simulations. So far I've been talking about steady state simulations, snapshot of the process in time. Well, a dynamic simulation is a process over time, how it's going to behave, maybe over several hours, and it includes modeling the control system, the DCS tuning parameters, the control valves, temperature controllers, pressure controllers are all added to the simulation, and now you run the simulation over time. Here we can do offline tuning to improve performance when the units maybe have coupled controllers. If the plant is brand new and it's never been started up, you can run a dynamic simulation and tune the plant to line out quickly before the plant even starts up. So dynamic tuning is a powerful simulation tool to help get a plant started up quickly. These are examples of simulation projects that Nassau EPC performs. Thank you very much.